Okay. Let me make sure this is recording and everything like that. Wait, what's going on? Okay, everything here. Awesome. Okay. Announcements. Homework 2 is out. You guys probably saw that. Exam is this Thursday in person. I think Professor Ames put everything, all the information up in the announcements. But the main thing is that it's just going to cover everything up till NumPy. So everything including NumPy. Anything that's related to pandas or anything after pandas is not going to be on the midterm. So what I'm going to do today is I'm just going to cover everything we've done up to this point, including NumPy in the short period of time that we have. That way you guys can diagnose what things you need a little bit of extra time on and what things you guys seem to be strong with, okay? These slides are also the same slides that we've been using. They're just a combination of them. But if you need the access to these slides, they're on file section on Canvas. There's also a bunch of practice problems there as well. I think they're a bit difficult than you would see on the exam, but it doesn't hurt to try them, okay?
Wait, what are those practice problems?
In the slides.
Oh,
So I'm gonna skip like a bunch of slides, but those slides will have some practice problems. I'm kind of mimic them from like last semester's practice problems, like the exam problems from last year. So that's why I have them included like that. But since it's in person, it might be a little bit more easier. Not making any, promises, but it's gonna be different in person. Okay, so how do I do this? Okay. So we started off with Python data structures, and there were three main types. We had lists, we had sets, and we had tuples. They differ on the basis of two reasons: mutability and order. Mutability is simply the ability to change. So how you can change that data structure, and then order. So how you access the elements in there. Okay, this is the first data structure. It's simply a collection of items. And this is how you declare it. You use names with a comma, not comma, square brackets, and you can fit anything in there. Lists do not require a single type. You can put different types in a list. So in this one, it's just a string list, but you can have multiple types in this list, okay? A good way to remember it is an array list in Java. But the thing with an array list in Java is that you would have to declare it as like an object, if that makes sense, not as like an integer array list. So that's just one way of remembering it. Lists can also be nested, so you can put a list within a list, okay? And so you would access it as such. So like if you wanted to access like the noise string, you would do 420, which is 0, false, which is 1, and then the list within that's going to be position 2. And then you access the list within the list. So if you access it as position 2, and you access it as position 1, because 69 would be position 0 within that list. Okay, lists are mutable, which means that you can search within it, you can add items within it, and shift, and you can delete items. And these are the methods that you can use. Element in list will return a Boolean value. So if you're doing an if statement and you want to see if an element is within a list, just simply put the element in and then the list name, and then it will return a Boolean value, true or false. And then you have the other methods for adding, shifting, and deleting items. Now, tuples are immutable. Now, tuples are a different type of data structure. Think of it like a coordinate, but like you can have like different values within that coordinate. And so in this case, I have like a name, and then I have like the grade of that person, and you declare with parentheses. And then to make sure, if you want to have like a one element tuple, you're allowed to have a one element tuple. But if you want to declare that, you have to make sure you add the comma at the end. So in the case of this example right here, to declare a tuple, it'll be the name and then comma, okay? If you don't put the comma there, it's not going to register as a tuple. And then a very common application of tuples is an array of tuples. And so if you see in this array of tuples, and rather than having like nested lists with names and like, grades, we have a tuple. And the reason why we use tuple is because it's just a lot more efficient. Okay. Why would we prefer tuples over lists? When you don't want the value to change because they're immutable. And on top of that, it's less memory. And this becomes very important with big data sets. We talked about this in the second recitation, but what should this output? We have this sort of tuple, and then I'm trying to access this element of a tuple, and I use the assignment operator to change hello to hi. And so when we print out the tuple, it should print out an error because we can't change the tuple value. Okay, so although it looks like something that we would work, this doesn't actually work. Now, set is just a collection of unique elements, so it's not going to have repetitive values. So if you have like 5, 5, 5, 5, it's only going to keep one of those fives, and it's going to store that as a collection of that element. There's no really specific order with it, and it's mutable. I think the prior Python documentation might say that's immutable, but you can add, replace, and modify elements within it. You're going to use the the curly brackets to create a set. This is a practice problem. Given a list of numbers, write a Python function to find the second largest number in the list. And so this would be the answer. You first are given the list of numbers through the arguments. You declare an argument with def, the list, method name, and then the arguments. You sort the list, so from smallest to largest, and then a cool thing is rather than iterating it and finding like the last value and then finding the value before that, you can just use -2 to access the second last element. If you want to access the last element, you would use -1. Okay, another example, given a list of tuples, each containing a name and an age, write a Python function to sort the list of tuples based on the age in ascending order. So basically, we're given an array, a list of names and age, and we have to sort it based on age. And so we could do this all in one line. We can return a sorted list with the key being the second element of the tuple. How this works is think of lambda as its own function. So lambda x, it's taking a x element, and so x would be the like the argument, and then it'll access x, the second element. So x is the tuple that it's taking in. So the lambda function is taking in a tuple, and then it's sorting it based on the second element. And the second element is the tuple position 1, because position 0 would be the first element. Given two lists of numbers, write a Python function to find the elements that are common to both lists and return a set of the common elements. And so we can use a property of sets, and we can first convert the list into sets, and then that should find like the unique elements, and then we can use a property of sets, or something that we can use with sets. In this case, it's the and it'll return a set with values from both those two sets. Okay, so that was recitation 1 material. Now let's get into recitation 2 material. This is just a review of the recitation 1 material. I left it in, but basically these are the functions of lists, and that's there for your look back. Okay, now I didn't really discuss this in the first recitation, and maybe I should have, but these are basically the set operations, and so there's 3 main ones: union, intersection, and difference. Union is exactly what you would think it is. It basically combines the two sets together. And like I said, sets are only unique elements. So as you look at set A and set B, 3 is in both of those sets. But if you look at the set it returns, it's not including 3 twice, because sets by definition can only contain unique elements. And so when we use the union, it'll account for that. So that's why we only have 5 elements rather than the 6 elements that we would have expected if we would to, like, in our heads, unionize those 2 sets. Intersection is basically all the elements that are contained in both sets. So now this is where the 3 would actually come up, like, more prominent, because 3 exists in both of those sets. Think of it as a Venn diagram. What elements are on one side, what elements are on the other side, and what elements are in the middle. So think of intersection as that Venn diagram. Difference would be, well, this depends on how you write it. So in the case here, I'm like set A difference of set B. And basically it looks at the stuff that are in set A that are not in set B. So in the case of set A, we have 1, 2, 3. 1, 2 do not exist in set B, but 3 does. So it does not include 3 in the final set. It only includes 1, 2 because that's the difference between set A and set B. And if we reverse that and put set B minus set A, it would be 4 and 5 because 4 and 5 don't exist in set A, but 3 still exists in set A. Okay, so it says here code and implementation for the most common grades where you're given a list of tuples with name and grade and assume all the grades are integers. This is the entire implementation of it. But the reason why I access it as like this is to show you a little bit later why we need dictionaries. But the way that I've set it up is like we're seeing the frequency of grades and we're assuming that all the grades are integers. And so we have 101 values from 0 to 100, 0, 1, 2, 3, 4, 5, 6, 101 values. And so whenever we find a grade, we increment that value. The issue is with this is that it's not really a great way to like, do a problem like this, like an answer like this. But if we were forced to use this, of course, this would work. This works completely fine. It's just not really an elegant solution because we're basically creating a list with 101 elements, and then we're accessing it by the position. It would be much more easier if we had something else where we're accessing it by the grade and not by the position itself. And that's when we learn about dictionaries. So dictionaries are basically key value pairs and the keys are unique. And so they will always have like a key and then you can access that key like you would access a position in a list. You know how you would use a list with numbers like in a list, for example, you'll have like the list name and then the position that you want to access. In the case of a dictionary, you can access it with some sort of name. So if I wanted a name, for example, I can access it as such rather than having that. And this is a lot more better because I don't need to know where it's stored. I just need to know the name of what I want that is stored. Okay. And dictionaries are pretty cool. The way that you can remember how dictionaries work is think of it as like an actual dictionary. When you're finding a word in a dictionary, when you're finding the definition, the value of a word in a dictionary, you're not looking at the page number, you're looking at the word itself. You're trying to use the word as the key rather than the page number as the key. This is the syntax. So dictionary 1 would be used with square brackets, and that's an empty dictionary. You can also create a dictionary just simply by keys, by using dig from keys, name and grade, and that's a list. And then you could also do key value pairs straight from the get-go. And then you can add them as you go. Okay, so these are the different functions. You have just accessing it in square brackets. That's the easiest one that you probably would, that's the easiest one. And that's how you access values. But the issue is that what if the value doesn't exist? And so that might issue an exception or an error. So there's a method that allows you to, that does that for you. It will be d.get, and that accesses the value associated with the key k and returns none if the key is not in a dictionary rather than raising an error. If you want to look at all the items, there's a method for that. These are items, so the dictionary name.items, the method. It'll just give you all the items. Same thing with keys, and the keys one is probably more of a prominent example that you would use because when you're making a for loop and you want to iterate through the dictionary, you want to iterate through the list of keys and then access it by list of keys. So what I mean by that is, you would make a for loop like for a key in dict dot keys. Okay, and then you can for example just print out the key, for example, the item that the key is associated with. Okay, so that's one application of how you would use it. Yeah.
What's the difference between a dictionary and an array of tuples?
An array of tuples.
Mhm.
So an array of tuples, it's how you access the element. So what are you how are you accessing an array of tuples? You're using numeric values. So you would need to know the position of that. You would need to search it. It's a cool way. It definitely has its perks, But with dictionaries, it's a little bit more different. You can access it based on name. So you might not necessarily even need a tuple. So in the case of tuple, when I used previously was, I would always put like a name and then like a grade. But in dictionary, you wouldn't need the tuple altogether. You would just make the name the key and then you would make the name the key and then the value the grade. Okay. And so this makes it a little bit more easier to access because then you can access it simply by the name rather than the position within the list. It's also optimized better. And so what I did here was that I changed I added dictionaries. So you're allowed to use dictionaries for the problem that I had previously. And now the solution is a little bit more better. Basically, if we create a dictionary of grade counts. So like if someone got like a 5 or like 100, something like that, it will be stored in a dictionary. And if it does exist, then they just simply increment that value by 1. And if it doesn't exist, then they just add value 1 into the dictionary. So that's how you can calculate the frequency of dictionaries, and it becomes a lot more simple. You don't have to get really messy with the code. It's a very simple implementation. Yes, look at that. Okay, list comprehensions. I know for a fact this is going to definitely be on your exam. So keep this in mind. Because I was half the exam last semester. Okay, so what is a list comprehension? It's just a concise way of creating a new list based on an old list. Benefits of list comprehensions: conciseness. They're all on one line. Readability, very simple to read. If you see it all on one line, there's not like a bunch of lines that you have to comprehend. And efficiency. I think that goes without explaining. The basic syntax of a list comprehension is right here. So basically, the expression is what you're adding to the list. For item in iterable means what you're iterating through. It's an iterator, something that you can iterate through, like a list, like a tuple. So something that you can iterate through. And so think of that as the for loop. And then the if condition, that's optional, but if you want to filter those values, I think the best way to understand list comprehensions, of course, is by an example. Okay. So if you look here, we have 4 lines of code. And basically what I'm doing is I'm appending the value up until 10, not including 10, into the array, and then I'm printing out the array. That's 4 lines of code to print out 0 to 9. But that is equivalent to, I have too many these transition things. But that's equivalent to I for I in range 10. How it works is it's adding the I value into the list every time the iterator iterates. So for I in range 10, it's iterating through 0 to 9, and it's adding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 into the array. And it's doing so all in one line. And so when you print it out, it should give the same output. Okay. And you could do the same thing. You can also do nested list comprehension as well. It gets a little bit tricky, but it's certainly the same syntax. You guys can get the pattern. So in the example here, what I'm trying to do is find all the different combinations that we could do between these different elements. And so what I did was I created a tuple. Tuple is this tuple here is what we're adding to the list. So XY tuple is the each element of the list can be added through each iteration. So it'll iterate through for X list 1. So it'll iterate through list 1 first. It'll look at 1, and then it'll iterate through list 2, and it'll make a thing for each of them. So it'll be 1A, 1B, 1C. Once it iterates to the list 2, it'll go back to list 1, 2A, 2B, 2C. And then finally it iterates again 3A, 3B, 3C, and it adds it every single time, and it outputs this sort of list of tuples. Okay. So given a list of numbers, create a given a list of numbers, create a new list that contains only even numbers. So let's say if we have numbers from 1 to 10, and we only want to include even numbers, then what we could do is add num for num in numbers. So num will be the thing that we added to the list. It'll iterate through a list of numbers. So the numbers is 1 through 10. And it'll be like if num modulus 2, you guys know what that means, but basically if it's a remainder of 2 is equal to 0, then that's an even number. And so if that is a true statement, it'll add that number into the list for each iteration. So it'll be like 1, okay, is 1 modulus 2 equal to 0? Hell no. So we'll skip that. 2 is 2 modulus 2 equal to 0? Yeah. and it'll add 2 to the list, and then it'll keep going until it reaches 10. Given a list of words, create a new list that contains the length of each word. So let's say we have a list of words here, and we want to create a list of word lengths. What we can do is we can just simply get the word. We can iterate through the words. So for word in words, and keep that in mind that these two things are two different things. So for word and words, these are two different things. Words is the list of words, and then word is the thing that you're accessing through. I know it may not be so clear because it only differs by one letter, but just keep that in mind. So word is just going to be a new word that it iterates through. So it'll be apple, banana, cherry. And then what we're adding to the list is not the word itself. What we're adding to the list is the length of that word. So 1, 2, 3, 4, 5. That's the length of apple. And so that will be added to the list. 6 would be for banana, and 6 would be for cherry, and it will add that to the list. Okay. Given 2 lists of numbers, create a new list that contains the product of each pair of numbers. The answer is here as follows, but it's the same process. You iterate through an iterator, and then what you have at the beginning of the list comprehension is what is added to the list, okay? I have a bunch of these list comprehension problems that you guys can do, and so definitely try it out, okay? I'm gonna skip through them. Okay. So now let's talk about the Python map function. So the Python map function applies a given function to all the elements of something that you iterate through. So let's say that you want to apply, let's say, the length function to all the elements of a list. Well, you can use the map function in that case. So I have a list of names, for example, here with a bunch of, my friends' names. And so I want to see the length of each of their names. And so what I do is I use the map function. The map function will take in 2 arguments. The first argument will be the actual function. In this case, it's length. You don't have to put the arguments because it knows that the arguments will be the second thing that you add. And then names. So names is the list. And so that's what you're going to be applying the function onto. And so what map does is then it applies length on, my name, Umar, Abul, Sama, Samir. That goes through all the names. And then creates a map object. You convert that into a list. And then once it converts into a list, it will output the different length values. So 6, 4, 4, 6, 6. Okay. So let's say if we're given this problem, given a list of numbers, use map to multiply each element by 2 and then return the result as a list. So there's 2 ways that you can do it. You can create your own method, or you can use lambda. I think in the solution here, I used lambda. And so we have a list of numbers 1 through 5. And so we have this sort of result that we're going to put the answer in, and we use the map function. And how do we make the function itself? We use lambda. How lambda works in this case is lambda x is the argument. So lambda is specifying that we are making a function. X is the argument that we're taking in. And then what are we returning? We're returning x squared. And so that's why we have colon x squared. X before the colon is the argument. X squared after the colon is what we're returning. And so we're applying this function. We put a comma, that's our entire function. And we apply that entire function onto the numbers list, okay? And so this creates a map object, and then we convert that map object to a list. And so when we print out the result, it should print out each of those elements, but they're multiplied by 2, okay? Given a list of strings, use map to convert each string to uppercase. So there's a function in Python that lets you convert a list of strings into uppercase. So we have strings, for example, hello world, how are you? And so we again use the map function. We get lambda x. Lambda specifies the function. X is the argument. And then so what do we do with x? That is a string, right? And so all we do is we use the upper method, and x dot upper will increase put all the characters in the string to uppercase values. And then what do we apply it to? We apply it to the list of strings, and that's the string, that's the list name. And when we print out the result, it should print out all of that. Yeah.
So why for this did you have to do lambda x, but for the last one, you just do lambda?
Did I mess up on the last one?
I mean, the one before,
What do you mean?
it was just like you put in just LEN to the length function, so lambda x.
Oh, because length is its own function. Length is a function that I'm making.
Mhm.
Length is a function that Python already has. Let's put it like that.
Okay.
So lambda is a function that I'm making myself. It's almost equivalent. Let's put it like this. Another way you could do this problem would be to define a function. Let's say we're doubling it, right? So we duck double, and then it takes in some type of argument x, and then we return 2 times x. And so if we're doing it this way, we would have to do the result like this. So result is equal to list map double and then numbers. So think of this equivalent to that, okay? But more closely, like notice how it's double and length. Yeah. Okay. Yeah. So we got that. Yeah. So other practice problems for you to do as well. Yeah. Go ahead.
Since like. Wait, number one, I saw it, so.
You're good.
Yeah,
All right.
that's what that-
So yeah, there's a couple of these practice problems for y'all to try on your free time. I made a lot of these problems. Okay, so Python zip function. A Python zip function basically creates a zip object. And so the the arguments for this zip function is an iterator. Iterator again, list, tuple, like the data structure that we discussed in the beginning. Okay. And so what it does is it combines the first element of the first iterator, the first element of the second iterator, and if there's a first element of if there's a third iterator, it also gets the first element of that, and the first element of every iterator that it's given, and then combines it into a tuple. And the tuple is stored as the first element in a list. Okay, so that's a lot of that's a big mouthful. So I have an example here. So we have names and we have majors. It's two lists, two iterators. And so when we use the zip function, what happens? Well, what happens is that Alice and CS get tied into a tuple, and so they're stored as the first element. The second tuple will be Bob and Matt, and so that will be the second tuple within a list. And the third element in both these lists are car and physics. So car and physics becomes a tuple, and we're added as the third element of the list. Okay. Now this is not exclusive to just two iterators. You can use 3 iterators. You can use 4 iterators. And in that case, we'll have the first element of names, majors, and then like the third iterator and the fourth iterator, the first element of those, and then those get combined. So if I had 4 iterators, assuming that, let me give you a problem like this. Assuming that all the lists or the iterators that I give you are the same length, and I give you 5 iterators, what would be the length of the tuple, each tuple? The length of each tuple would then have to be 5, because for each iterator, there is some type of data point. So Alice comes from the first one, CS comes from the second one, third one, fourth one, and fifth one will come from the third, fourth, and fifth iterators respectively. All right, so given 2 lists of numbers, use zip to add the corresponding elements of each list and return the result as a list. Okay, so we have a list 1, 2, 3, 4, 5. We have another list 10, 20, 30, 40, 50. These are lists of the same value. These are the lists of the same length. And so what we're doing here is creating a result list, and we're using list comprehension. So we're not leaving our list comprehensions in the past, we're bringing them in. And so what I'm doing here is, again, there are more easier ways to do this. You don't necessarily have to do it like this, but I'm just illustrating how you can use the zip function practically. And so in the case here, what we're doing is we're iterating through a list 1 and list 2. So for For xy is basically a tuple. So for xy, it's iterating through every tuple within the iterator. The iterator is zip list 1 and list 2. And so think of it as a list of tuples that contain values from list 1 and list 2. Okay, so in the case here, for example, this sort of zip list 1, list 2 value. I don't know where I put it. This sort of list 1, list 2 zip function is going to be 1 and 2, 20, and then it keeps going like that, stored in a list. Okay, and then it just adds those values together. And when we print out the results, we get 11, 22, 20, 33, 44, 55, because it's adding the first element of the list 1 with the first element of the second list, second element of the first list, second element of the second list, and adds them together. Okay. So yeah, these are other problems that you can use with lists. Okay. So I'm not going to hold you up to that, but you guys can go back and check that out. All right, so let's do some file IO. I don't know how much of this you'll be tested on, but I think you should at least have a working understanding of it. To open a file, you simply just use the open function. And so open will be open parentheses, the file name. Now, if the file is in the same folder as where you're storing the Python file, you just simply got to list the name of the file. So sample.txt is in the same file, it's in the same folder as my Python file. Then you could just do it as sample.txt. Now, if it's not, then what you need to do is put the path within those quotation marks. And so that way it can find it. The 2 quotation marks around R as the second argument emphasizes that we're in read mode. Read mode means that we're only reading the CSV file, or in this case, the TXT file. We're not editing it. We're not going to be appending anything to it. We're not going to be removing anything from it. We're just viewing it as a file, and we maybe extrapolate some data from it, but we're not at the end of the day changing the values in it. And then we use the assignment operator to store that TXT file within F. Okay. So we can use the f.read function to read the entire file. And so it's very simple. We first put the file and store the file in F. Okay. And then we use the read function to store all the contents. And so when we print out all the contents, it'll print out the contents because we told the read function, or we use the read function to access all the elements. And then we close it because we don't want to, have that data set open for anyone to use it just yet. Now, read lines is a little bit more better because you're not reading an entire file just yet. Okay. What you do, let's put it like this: it formats your string that you're storing the contents of the file in. So read lines is a method of a file object in Python that reads all the lines of a file and returns them as a list of strings, where each string represents a line in the file. So rather than having an entire string with everything in it, which wouldn't be practical, what it's doing is it's creating a list of strings, and each list element within that list of strings is a line. Okay, so every time we access, let's say, position 5, for example, that is the 6th line for it. Okay. And so we can use it as such, and we can print it out as 4 line in lines, print out line. And that's how we can print out all the contents if we were to read all the contents of the file using the read lines function. Okay. Now close is important because you want to close the file once you're done. And this is mainly just to free up resources. Now you can use a function or a keyword called with to actually read a file. And there's many reasons why you could use this, but the main one is that you don't really have to close the file once you're done. You just don't indent it anymore because it's like an indent. So it's like with, and then you open with this file name, and then everything you do underneath it is what you're doing with the file. But then once you no longer indent it, you're done with the file. So you don't have to close it, which is pretty cool. Yeah, there's another thing I'm missing out on. Oh yeah, and the case that there are exceptions, it'll take care of that. So that's another cool reason why you should use with, because it'll tackle those exceptions. Okay, so it says here, write a program that opens a file named numbers.txt and prints the sum of all the numbers in the file. The numbers in the file are separated by new line characters. Okay, so it has a file 1, 2, 3, 4, 5. And basically what I'm trying to do here is add up those values to output the value 10. And so the answer then would be to first open the file with and we have it in read mode because we're not going to be editing the file. We're just going to be reading the contents of the file. We read it in the lines. This is a really good way because we only have numeric values. Remember what I showed you guys in the file? It's only 1, 2, 3, and 4, and each line represents a new number. And so by reading lines, each of those numbers are going to be stored as a string within a list. And so that would be cool because then all we need to do is convert those strings into integers. And that's what we do. We create a new, we store it in the same variable. And we have this list comprehension that basically converts all the string lists that we got from the read lines function into integers. And so now we have a list of integers, and all we need to do is find the sum of that. And that's what we do. The total is equal to the sum of the numbers. And then we print out the total, and it should print out as such, okay? So you could do these other example problems as well. So I'll leave that to you guys. Reading functions. So there are multiple reading functions. Read n is basically just reads n characters. So it reads from where you are to n characters. A tell is simply like where the pointer is. So when you're reading, think of reading literally as like actually reading a book. So you're using your pointer and you're reading the book like this, and think of the computer doing exactly like that. And so tell is basically going to tell you where the pointer is. So where the heck is the computer's pointer? Where has it reached in the file? And then seek is tells you where to go. So if it tells you, okay, go back like 5 words or 5 words, technically 20 characters. Go back 20 characters, it'll go back 20 characters. In this case, it's from like the very first, so it wouldn't be go back 20 characters, it would be like go to like the 50th character when you're at the 70th character. Okay. And so these are the reading functions. Okay. This is the syntax for read. You guys can look at that, tell, and seek. And there's example problems as well for that. So there's different file modes. Like I mentioned, the first one was read. And so that basically means what? That you're just reading the file. The second one is write. And that's basically if you want to create something or if you want to truncate something. You can create a new file or you can edit an existing file. And the third one is append. Basically, you're adding something to an existing file. So when you write to a file, you use the write function. So you're like with open output.txt, and then notice what's in quotation marks. We don't have the R anymore. We have the W, and we open it as file. We write to the file f.write, hi there, and then we write lines. We could do the same thing. So we can write either all together, and then we can use the /n as an escape sequence to start a new line. Or we could do it a little bit more simpler and write it as a list of strings. And as you notice in the list of strings, it's in the write lines function. And so every element of that list becomes a new line. Yeah.
So, what would the output be?
What's up?
What would it show after I look at the file?
It should for now, first it writes hi there. Okay, and then it's like that line is done. So that line doesn't exist. This is not part of the file, but I'm just saying that the line doesn't exist anymore. And then after that, it's hi. And then escape sequence, no longer new line, and then it's there.
So like technically, do I still need the new line character?
Right?
Do I still need it there?
I don't think so. Yeah, I don't think you need to, but just check to make sure. Yeah, so basically what it's saying is you can remove the /n. right? Collections is a module that you can use in Python that provides alternate data structures to the built-in data structures in Python. So we've already discussed three of those data structures, which were lists, tuples, and sets. But collections allow you to make like deviations of those data structures that have pretty cool applications. And so these alternate data structures are more efficient and they're more practical in different scenarios. Okay, so we have this sort of default dictionary, and the cool thing about default dictionary is that rather than having, when like someone accesses an element and it gives like a null value, you're not going to have that with a default dictionary. With default dictionaries, it'll have a default value whenever you access an element that you previously did not instate. So the default dictionary is pretty cool because if we access an element, if we access an element, it will never give us like an error that it doesn't exist because it has a default value there. This is pretty cool because you can use this in the context of frequencies. So you can have it set so that if you're looking at the frequency of I don't know, rain locations, but let's say a location never rained, you don't have data on that, then rather than saying, oh, we don't have data on that, we can be like, it's 0. Okay, so there's some practice problems with that as well. There's a counter, so you can use that. And there's other things you can check out as well, name equal and DQ. I don't know if we emphasize that in lecture, but just know it in the back of your head, but I don't think it's too important. All right, so this is what we covered last week. This is NumPy. NumPy is really good because it basically synthesizes informations into arrays that we can do pretty cool stuff with. Okay, the text is so small on my end. But basically what you need to do is import the library as import NumPy as NP. You can import it as NumPy, but whenever you see like NP, for example, in your file, you need to replace that with NumPy. It's just easier importing it as NP. That way, whenever you access the NumPy library or class, you only need NP characters. Okay. So in the case here, we're basically creating a NumPy array with a list of values 1, 2, 3, 4, and 5. And we can do the same thing here with a nested, not nested, but actually, yeah, it is technically a nested list. How many elements are in this outer list? So if someone were to ask you how many elements are in this outer list, what would it be? So if we did the length function on that entire list, what would it return? Yeah, it would return 3, right? Even though there are like 9 numbers in there, it's only going to return 3 because it looks at the elements on the outer. So this list is going to be the first element, this list is the second element, and then this list is the third element. Right? But if we were told to find the length of this element here, then it would be 3 again. But in this context, it would not be 3 lists, it'll be 3 numbers. So the difference between lists and NumPy is that NumPy is going to be in one data type. Lists can be multiple data types. If you remember for the example that we gave, lists we could put like any type of value, it'll work. But NumPy, what it'll try to do is it will try to change it all to a single type. So in the example here, I have 1, 2, and 3.5. What it does is rather than keeping it as 1, 2, and 3.5, it converts all 1 and 2 to 1 point and then 2 points and then 2.5. It converts them all to floating point numbers. In the case here, 1, 2, and true, what it does is it converts true into an integer value. And you've taken, I think, the class in C, 0 means what? False, 1 means true. So think of it exactly as that, and so it keeps it as integers. In the case here with 1, 2, and 3, the 3 is in the string form. It doesn't know that that is an integer string form, and so what it does is just elevates all the other values into strings. And so 1, 2, 3 become string forms of 1, 2, 3. I am running out of time, so these are just the certain data types that you have in NumPy. This is a way how you can specify data types in NumPy. You would do np.array with a list, comma, you specify the type is equal to np float, or the list of values that you have here. Okay. There's different attributes. So ndim is basically how many dimensions there are. And then shape is literally the actual shape. So like the number of rows and the number of columns. Think of it exactly as that. And if it's like a messy array where it's not really consistent, then like we mentioned before, shape doesn't really work in that case. And you can't change shape directly. You would need to change shape by the reshape function. And then once you change reshape function, it'll adjust the shape attribute. Okay. And since it's an attribute, you don't access it with what? Parentheses. It's a attribute. It's not a function. Functions, you would use the parentheses. Okay. These are just some notes on the dimensions. Can NumPy arrays have rows of different lengths? Yes, they can, but it's not ideal because when you're writing a program, you might mess up and you might have the rows shifted. And so it's better to have them the same rows and columns, like, you know, the same length. But if your program is adjusted to do that, it's not going to, like, you know, give you an error. These are different functions that you can use in NumPy. So zeros basically creates a zeros NumPy array with the number of zeros as the argument, and ones is the exact same thing, except it replaces the zeros with ones. Empty creates a initialized NumPy array. Creates a identity matrix with n being like the n by n rows and columns. You can also dude, this is like mad small on my hand. You could use underscore like to create a NumPy array based on another array. So let's say I have another 3x3 array and you wanted to create an identity matrix with that. You can do well, if you wanted to, let's put it like this. If you wanted to create an empty array, I don't think I have that example here, but if you wanted to create an empty list, but based off the dimensions of another NumPy array, then you would do empty underscore like. Same thing with zeros and same thing with ones. It would be ones underscore like, zeros underscore like. Okay. Like I mentioned previously, if you want to change the dimensions or the shape attribute, you cannot change the shape attribute directly. You need to use the reshape function. You can combine, arrange, and reshape together. And you can see that example here given as such. Again, I'm just breezing through it. But if there's something that you need a bit hesitancy on, just, you know, use this as an opportunity to realize that that might be something that you have to brush up on before the exam. You access elements in NumPy array like you would with a regular list. You would just index the block, index the row, and then index the column. You can also index a multitude of values. You don't have to just index one value. You can index multiple values using a colon. So if you want to index all the elements of a row and all the elements of a column, you would just replace the number with a colon. And so this is just a fancy problem, but it's basically an identity matrix where the diagonal is 5 and then the rest of the values are 1. And so we can construct it like that. Views versus copies. Just remember that when you are constructing a NumPy and using NumPy in your programs, there is a difference between views and copies. One could be like, you know, you're viewing a slice data, but you're not editing the original array, or you're looking at a copy of the original NumPy array. So keep that in mind and make sure that you don't, like, you know, edit the slice, but when you really wanted to edit the main NumPy array. And so that's how you can slice on multidimensional arrays. There's some Boolean indexing as well. So if I only want to look at the NumPy values, if I wanted to only look at values of a column where, like, let's say if I wanted to only look at the students that had grades greater than 5, or not greater than 5, greater than 70, it'll be grades greater than like 90 or something like that, depending on the grade that you would want. And so this is a really good way of subsetting data. And then finally, this is the last slide. If you want to transpose data, you can just simply do scores underscore dot t, or like the name of the NumPy array dot capital T. And that will transpose the array for you. All right. So those are all the slides that we've done up until this point in recitation. I wish you guys the best on the exam. I'll see you guys there.
Proctoring?
Yeah.
Are you gonna be able to announce those slides?
It's on Canvas.
Yes.
Yeah.